Cozumel is an island in the Caribbean Sea off the eastern coast of Mexico's Yucatan Peninsula, opposite Playa del Carmen and close to the Yucatan Channel. Jacques Cousteau is credited with introducing Cozumel to the world as a premier dive site in 1961 when he filmed a documentary on its stupendous coral reefs. Cozumel, located in the northern edge of the Mesoamerican Barrier Reef, is second in size to the world after Great Barrier Reef in Australia and is the largest coral reef in the Western Hemisphere. The Mesoamerican Barrier Reef System is a marine region that stretches over 1,000 kilometers from Isla Cantoy at the tip of the Yucatan Peninsula down to Belize, Guatemala, and the Bay Islands of Honduras. The reef system is home to more than 65 species of stony coral, 350 species of mollusk, and more than 500 species of fish. The reef system is home to one of the world's largest populations of manatees, with an estimated 1,000 to 1,500 of them. Some northern areas of the reef system near Isla Cantoy are home to the largest fish on the planet, the whale shark. The normally solitary whale sharks congregate there in social groups to eat and to mate. Since the airing of the Jacques Cousteau special in 1961, this largest of Mexico's islands located in the Caribbean has grown into a leading dive and vacation destination. The Maya are believed to have first settled Cozumel by the early part of the first millennium AD. The island was sacred to Ixchel, the Maya moon goddess, and the temples here were a place of pilgrimage, especially by women desiring fertility. The first Spanish expedition to visit Cozumel was led by Juan de Grijalva in 1518. In the following year, Hernan Cortes stopped by the island on his way to Veracruz. The Grijalva and Cortes expeditions were both received peacefully by the Maya of Cozumel, unlike the expedition's experiences on other parts of the mainland. Even after Cortes destroyed some of the Maya idols on Cozumel and replaced them with an image of the Virgin Mary, the native inhabitants of the island continued to help the Spanish resupply their ships with food and water so they could continue their voyages. As many as 10,000 Maya lived on the island then. But in 1520, infected crew members of the Panfilo Narvaez expedition brought the smallpox contagion to the island, and by 1570, only 186 men and 172 women were left alive on Cozumel. In the ensuing years, Cozumel was often the target of attacks by pirates. The three most famous reef systems on Cozumel are located on the southwest side of the island. Columbia Wall, Palancar, and Santa Rosa Wall are spectacular dives. Santa Rosa Wall is rated one of the top 50 dives in the world. These three magnificent dive sites start in approximately 60 feet of water and extend to the abyss. The famous vertical walls and swim-through are world famous. Santa Rosa Wall has a spectacular vertical wall. The big three on Cozumel are classified as edge reefs. Edge reefs are characterized by continuous structures rising into coral peaks high above the edge of the drop-off zone and extending to as much as 180 feet below the surface. Cozumel is also famous for its drift diving. Currents are usually mild, 1 to 2 knots, allowing divers to glide effortlessly among the reefs. The Gulf Stream runs along the entire coast of Quintana Roo, flowing from the south to the north, with its intensity depending on weather conditions, seasons, and the moon. Generally speaking, the current is stronger on the deeper wall dives at the edge of the shelf where occasional down-dwellings may be encountered. Photographers and videographers should be especially careful with the currents as they are often more focused on the subject than their surroundings. Novice and rusty divers with limited buoyancy control should allow more than the required 3 feet distance to avoid damaging the reef. The big three are breathtaking. The visibility during July is well in excess of 100 feet. The water is crystal clear. This is a truly remarkable marine environment and should be experienced by everyone. Since the beginning of the Industrial Revolution, the release of carbon dioxide, or CO2, from human activities has resulted in atmospheric CO2 concentrations that have increased from approximately 280 to 385 parts per million. The atmospheric concentration of CO2 is now higher than experienced on Earth for at least the last 800,000 years, and is expected to continue to rise at an increasing rate, leading to significant temperature increases in the atmosphere and oceans in the coming decades. The oceans have absorbed approximately 525 billion tons of carbon dioxide from the atmosphere, or about one-third of the anthropogenic carbon emissions released. This absorption has benefited humankind by significantly reducing the greenhouse gas levels in the atmosphere and minimizing some of the impacts of global warming. However, the ocean's uptake of carbon dioxide is having negative impacts on the chemistry and biology of the oceans. Hydrographic surveys and modeling studies have revealed that the chemical changes in seawater resulting from the absorption of carbon dioxide are lowering seawater pH. pH of ocean surface waters has already decreased by about 0.1 units from an average of about 8.21 units to 8.10 units since the beginning of the Industrial Revolution. Estimates of future atmospheric and oceanic carbon dioxide concentrations based on the Intergovernmental Panel on Climate Change, CO2 emission scenarios, and coupled ocean atmosphere models suggest that by the middle of this century, atmospheric carbon dioxide levels could reach more than 500 parts per million, and near the end of the century, they could be over 800 parts per million. This would result in an additional surface water pH decrease of approximately 0.3 pH units by 2100. When CO2 reacts with seawater, the reduction in seawater pH also reduces the availability of carbonate ions, which play an important role in shell formation for a number of marine organisms such as corals, marine plankton, and shellfish. This phenomenon, which is commonly called ocean acidification, could have profound impacts on some of the most fundamental biological and geochemical processes of the sea in coming decades. Some of the smaller calcifying organisms are important food sources for higher marine organisms. Declining coral reefs due to increases in temperature and decreases in carbonate ion would have negative impacts on tourism and fisheries. Abundance of commercially important shellfish species may also decline, and negative impacts on finfish may occur. This rapidly emerging scientific issue and possible ecological impacts have raised serious concerns across the scientific and fisheries resource management communities. Global warming is caused by the accumulation of carbon dioxide and other heat-trapping gases in the atmosphere. These gases act as a blanket, preventing the heat of the sun to escape through our atmosphere. This is primarily due to fossil fuel burning and deforestation, and many scientists believe that this is causing sea surface temperatures to rise. Ocean warming is extremely dangerous to coral organisms, which are very sensitive to changes in temperature. Increased water temperatures, which may be linked to global warming, can cause mass coral bleaching. This occurs when coral polyps, stressed by heat or ultraviolet radiation, expel the algae that live within them. These algae, called zooxanthellae, normally provide the coral with up to 80% of its energy, making zooxanthellae essential for coral survival. The algae are also normally responsible for the color of coral, so that when they're expelled, the coral appears white or bleached. There is a chance that bleached coral can recover if conditions return to normal quickly enough. However, in the face of other human-induced pressures, corals have become vulnerable. In many cases, bleached coral colonies die. In the past few decades, the amount of carbon dioxide in the air has increased by 1/3. This is harmful to coral because increased amounts of carbon dioxide are dissolving into the water, which appears to be dissolving the skeletons of corals. As a result, coral in waters with large amounts of carbon dioxide form weaker skeletons, making them more vulnerable to damage from waves, careless tourists, and destructive fishers. Scientists have identified pollution as one of the leading causes of coral reef degradation. This threat comes from a variety of sources. For example, oil, gas, and pesticide contamination poisons coral and marine life. Reefs are harmed when human, animal waste, and/or fertilizer is dumped into the ocean, or when river systems carry these pollutants to reef waters. These pollutants increase the level of nitrogen around coral reefs, causing an overgrowth of algae, which smothers reefs by cutting off their sunlight. Trash also kills coral reef animals. Floating trash can cover reefs, blocking off sunlight that polyps need to survive. Turtles often mistake plastic bags for jellyfish and eat them. Plastic blocks the turtle's digestive tract, causing them to starve to death. Lost or discarded fishing nets, called ghost nets, can snag on reefs and strangle thousands of fish, sea turtles, and marine mammals. Construction along coasts, inshore construction, mining, logging, and farming along coastal rivers can all lead to erosion. As a result, particles end up in the ocean and cover coral reefs. This smothers coral and deprives it of the light it needs to survive. Mangrove trees and seagrasses, which normally act as filters for sediment, are also being rapidly destroyed. This has led to an increase in the amount of sediment reaching coral reefs. Mangrove forests are often cut for firewood or removed to create open beaches. They are also destroyed by prawn harvesters to open up areas to create artificial prawn farms. Mining also destroys coral. Sometimes coral pieces are removed for use as bricks or road fill. Or sand and limestone from coral reefs are made into cement for new buildings. But corals aren't only removed from their habitat for construction, they are also sold as souvenirs. Coral curios and jewelry are often sold to tourists and exporters in the markets of developing countries. Tourist resorts that empty their sewage directly into the water surrounding coral reefs contribute to coral reef degradation. Waste kept in poorly maintained septic tanks can also leak into surrounding groundwater, eventually seeping out to the reefs. Careless boating, diving, snorkeling, and fishing can also damage coral reefs. Whenever people grab, kick, walk on, or stir up sediment in the reefs, they contribute to coral reef destruction. Corals are also harmed or killed when people drop anchors on them or when people collect coral.